Diffusion can be explained by a simple example. Here, an environment is divided into two parts by a semi-permeable membrane. There are 8 molecules in part A and 2 molecules in part B. These molecules have no electrical charge. Each molecule has random motions that are caused by kinetic energy. These movements are called Brownian motions. The result of Brownian motions is the movement of molecules from the part with a higher concentration to the part with a lower concentration. Finally, this environment reaches a dynamic equilibrium due to the absence of a concentration gradient. In this example, 5 molecules in each part bring the environment to the most stable state. The molecules can move between part A and part B, but their net motion is equal to 0. What has happened in this environment is called diffusion. Here, the movement of uncharged particles is affected by chemical force. In another environment, there are cations and anions, and the membrane is only permeable to cations. In this environment, the concentration of both cations and anions is higher in part A than in part B. So, the cations move from part A to part B, while the anions cannot pass through the membrane and remain in part A. This causes the membrane to become negatively charged on the A side and positively charged on the B side. Now, the concentration gradient causes the cations to be attracted to part B, while the electrical gradient causes them to be attracted to part A. Finally, the combination of both chemical and electrical forces equilibrates the environment. At this time, the net diffusion of cations becomes equal to 0, despite their concentration being higher in part A than in part B. Here, the movement of charged particles is affected by electrochemical force.